this lesson is going to finally get into the applications of matrices. So far we've done some arithmetic and other operations on matrices, and now we're going to actually talk about how we can use those things to solve a system of linear equations, which is essentially one of the major applications for matrices. So first things first, we need to know how we would represent a system of equation with a matrix and what a system of equations is. So if you remember from your algebra classes, you should any equation is something set equal to something else. A system of equations takes several of those equations and puts them all together with typically multiple variables to solve for those variables. So if we have one equation, we can only solve for one variable. Otherwise, we're solving them in terms of each other. But when we've got multiple equations, we can say, okay, let's put all of this information together and see when all three things work together. And essentially what we're doing here is we're creating three lines in three-dimensional space, and we're talking about where they intersect. So if you kind of think about a three-dimensional grid like this, you might have those three lines intersecting at a specific point, and that is what we were looking for, that x, y, and z coordinate in this case. If it's two dimensions, then it would be a two-dimensional space. If it's four, then it would be a four-dimensional space, so forth and so on. So, looking at this system that we have right here, essentially what we do is we pull the coefficients, we make sure everything is lined up, all the x's, all the y's, all the z's we count as our columns, and so we take the coefficients off of x. So in this case 2, we don't have an x here, and a -1, so these are our x coefficients. Our second column is going to be our coefficients on y, so we're missing one here. We have a 0, and then we have a 4 and a 2, and a 2 as our other coefficients. And then finally, if we look at that last set of variables z, we have a 1, an understood 1 here, a 2 and a 2, so that's our final column. Then we take what is known as our variable matrix, which are those variables, but we put them in a column form because, as you remember, when we multiply matrices, we take the first row by the first column, and so this would be 2 times x plus 0 times y plus 1 times z, and that would give us our system over here. And then we'll set it equal to our other matrix, which we're going to call B. That is the constants over here. So with all of that, we kind of put everything together, and we write the equation down. So this would be A times x equals, and I'm going to leave a little bit of space here, and you'll see why in a second, equals B. That's what we have here. If we take A times x, we get all of this part here, and then we set it equal to B. Now, if we want to solve for x, in algebra we would divide by a, but we already talked about we don't have division in matrices. Instead, we have the inverse. So we are going to multiply both sides of this equation by the inverse, but we have to make sure that it's on the side that a is on, because again, multiplication is not commutative across matrices. So we need to make sure that if we're going to put it over here on the left side so that it's multiplied by a, then we also need to put it over here on the left side of b when we multiply. And so that was why I left that space there, because again, we have to do the multiplication in the same order. B times A inverse will not give us the same answer. In fact, it might not even give us an answer because the dimensions might not match. And then we go through, well, we know that A inverse times A is the identity, and it's still times x, and then we have A inverse times B over here, and we know that the identity, or 1 times anything, it just gives us that thing back. So we have x is equal to A inverse times B. So this is why we went through and found our inverses so that we could solve systems of equations. It's one way to solve systems of equations. So let's take a look at this first example. We've got A is going to be, again, our coefficients. If we read them off for the x's, are 1, 0, 2. And then if we look at our y's, we're missing a y there. Then we have a 2 and a 3. And then a 4, 4, and 6. One thing you always want to check when you're going through these is to make sure that none of the rows are the same, that we don't have the same equation twice. If we do, then we are going to run into some troubles as far as trying to solve these. In fact, they're typically not solvable. So that's our coefficient matrix. Our variable matrix is just going to be simply x, y, and z. And then B is going to be our negative 27, negative 16, and negative 30. So again, if you're going through and finding the inverse, we could go through and do it by hand. Typically, most mathematicians use a computer or a calculator to find our inverses. We might do a little bit of simplification if it's not too bad to start off with. Again, this one's kind of nice because we start off with those zeros here and the 1 already here, so we could do a little bit of manipulation on our own to start off with. But we could also just type it into the calculator. So go ahead and type it into your calculator. And again, if you recall how to put this in the calculator, again, you're going to go to Matrix, scroll over to Edit. We have a 3 by 3. And then again, we can go through and enter those numbers. So 1, 0, 4, 0, 2, 4, 2, 3, 6. Again, we quit out of that. We go back to Matrix. We again hit Enter because we want our first matrix. We hit our inverse button. And we end up with this here as our inverse. Again, if we want to go to fraction, we just go to Math and then frac, and it will give us to us in fraction form if we prefer that. Sometimes that's helpful. So if we write down our inverse here, we have 0, negative 3/4, 1/2, negative 1/2, 1/8, and 1/4, and 1/4, 3/16, and negative 1/8. Okay, so that's our A inverse. Again, if we wanted to solve this thing, x is going to be A inverse times b. So we can do that by hand if we want to. Again, we know how to do this by hand. Let's kind of work it out real quick and then we can check it in the calculator. So let's write down our A inverse b. So A inverse is our 0, negative 3/4, 1/2, negative 1/2, 1/8, 1/4, and 1/4, 3/16, and negative 1/8. And b is negative 27, negative 16, and negative 30. And again, if you go across each row by the column, so we've got 0 times negative 27 plus negative 3/4 times negative 16 plus 1/2 times our negative 30. And this is going to end up just being a column matrix. A column matrix is just a matrix with one column. And then we got our negative 1/2 by our negative 27 plus 1/8 times our negative 16, and finally our 1/4 times our negative 30. And then our last row here, our last element, is going to be 1/4 times our negative 27, 3/16 times our negative 16. That's kind of nice. That works out well. And then negative 1/8 by negative 30. So that 0 is kind of nice. That goes away. Negative 3/4 times negative 16 is going to give us 12, and a half of negative 30 is going to give us negative 15. So we end up with a negative 3. Half of negative 27 is going to be just 27/2. The 16 over 8 is going to give us negative 2, and a quarter of 30 is going to give us 7.5 or negative 7.5. When you put all of that together, you end up with 4. And then finally, a quarter of 27 is just 27/4. Like we said, the 16 and the 3/16 is just going to give us a negative 3. And then finally, an eighth of 30 would give us our 15/4. And when we simplify all of that, we end up with negative 6. So that is, again, how you could do it by hand. Once you found that inverse, it's not too bad to do the last step by hand. So let's take a look at another example here. We have this system here. Again, I'll help you write things down, and then I'll have you enter your answers in the online system. We've got our -1, 0, 3 as our coefficients on x. We have -2, -1, and 1 for our coefficients on y, and then 3, 2, and 0 for our coefficients on z. Again, our x matrix is just x, y, z, our variables, and then b is going to be our numbers over here, 37, 26, and 7. So at this point, again, we can go to the calculator to find A inverse, and then we can multiply it by B. So here is where I want you to pause the video and go ahead and do that, and then enter your answers in the online system. And then when you resume the video, we'll take a look at example 31. So example 31 is a 4x4 matrix. This one would be a lot more work to do by hand. We're definitely going to want to use the calculator for this one. And we have 4 variables, x, y, z, and w. So our coefficient matrix is going to be 4x4, so 2, 1, 0, 2. For the y's, we have 1, -2, 1, 2. -2, 4, 2, -4. And finally 2, 1, 2, 4. So it'd also be a pain as far as finding an inverse because we only have 1, 0 there to start off with. So it's possible that things might simplify as we go along, but it's again just a lot safer to deal with the calculator because these things are very easy to make mistakes with. So x, y, z, and w. And then finally B is our column matrix, -3, 61, 21, and -22. So again, if we're putting in the calculator, we have x is equal to A inverse B. So I already have the first matrix A in here. Again, it's a 4x4. Again, remember as you're going through here to go across the rows and then to the next row. Don't try to fill in by the columns if you're hitting enter. You can use the arrows to fill in whichever way you want, but if you're just hitting enter to enter your elements, then you want to make sure you go across by rows. If we go back and then go to matrix B, then we know that this is a 4x1. We got 4 rows, 1 column, and our elements are -3, 61, 21, and -22. And then our final step, if we quit out of this, is we are going to go back to matrix. We're going to grab A. We're going to hit that inverse button. We're going to hit times, and then we go back to matrix, and we're going to grab B. And so this is what it should look like on your screen. You hit enter, and you get your answers 8, -5, 10, 3. So those are our answers for x, y, z, and w. So you would say x is equal to 8, y is equal to -5, z is equal to 10, and w is equal to 3. And that's an introduction to how to solve systems of equations using this method with the A inverse times B. We'll talk about another method in the next video.